We left off with 6.5 nearest neighbor algorithm. We learned that the nearest neighbor algorithm is efficient, but it's not always accurate. It doesn't always give us the optimal circuit, like we got with brute force. So, is there a way we can improve it because we like the efficiency of it? Well, the answer to that question is absolutely. What we're going to do is we're going to compare from different starting spots. Compare from different starting spots. So, what that means is instead of always starting at A, we're going to do it at every vertex. We're going to start at A, and then we're going to move on and do it again and start with B this time, move on and start with C, so on and so forth until we run out of starting spots. So, here's your steps. The repetitive nearest neighbor algorithm. To perform it for every vertex, lost my marker there. So we're going to perform this for every vertex of the graph as the starting vertex. Finally, at the end, just like we did with brute force, we're going to compare the circuits and choose the circuit with the least weight of all the options. We're going to pick the optimal circuit. If needed, we may have to shift the circuit to start with the designated starting vertex first. So let's say that our shortest one that we had started at vertex C, but our answer needs to be at vertex D. We just need to shift it so D becomes our starting point. So we're not changing the order of it, we're just shifting it over to start somewhere else. And that takes us into our first example. So, we have this complete graph of 4 points, which means each one has a degree of 3. And they want us to perform the nearest neighbor algorithm, and we're going to do repetitive as well. So, nearest neighbor algorithm, if we start at A. When we start at A, our nearest neighbor is to go on to B. So A to B, and that has a weight of 9. From B, our next nearest neighbor is D, and that had a weight of 13, so we have to add 13 there. From D, we have to go to C, because remember, Hamilton circuit, we have to touch every point once, and only once, and then return home. So we must go to C after that, and that has a weight of 11. And finally, we must return back to our starting point, so we're going to return back to A, and that has a weight of 15. And when we put all that together, we have a total weight of 48. Again, because the nearest neighbor algorithm is not always optimal, we're going to perform repetitive nearest neighbor. So let me choose a different color here. Okay, so this time we're going to start at B. Actually, let me just erase what's on this graph so I don't confuse you here. If you just want to switch colors on your paper, that's fine, whatever you want to do. Okay, so this time we're going to start at vertex B. So our nearest neighbor, if I start at vertex B, is going to be leaving B, and we're going to head straight up to A. Again, that has a weight of 9. From A, our next nearest neighbor, we have our choices of D with a weight of 10 or C with a weight of 15. So we're going to travel across to the right to D and add 10. Oops, I didn't need 2 plus signs there. So weight of 10. And then of course we have to go to C. So weight of 11. And we must return back to our starting point, which this time was B. So that has a weight of 17. So let's see, 20, 30, 38, 47. And we're going to continue to do this until we've used every vertex as a starting point. Okay, so this time I'm going to start at C. When I start at C, my nearest neighbor is going to be D. And that had a weight of 11 plus. When I leave D, my next nearest neighbor is going to be A with a weight of 10. I must go to B before I return home. So if I go to B then, that has a weight of 9. And finally, back to my starting position. So we're going back to C, which is a weight of 17. And this also has a grand total of 47. We have one more vertex to start at. So we're going to go ahead and start at D this time. When I start at D, my nearest neighbor is A. So we're going to go this way to A with a weight of 10. From A, my nearest neighbor is B. Oops. B with a weight of 9. My next nearest neighbor, well, I have to go to C. Gotta stop at every stop. So we're heading to C with a weight of 17. And finally back home to D with a weight of 11. Which also gives us a grand total of 47. So any one of these 3 could have been our optimal route. So you can pick any one that you want, it does not matter. Notice though, it says at the bottom, final answer has to start at point A. So one of these are going to have to be rerouted to start at A. So let's take a look at the first one, the one that started at vertex B. So we just need to rewrite this so it starts at point A. So all we're going to do is we're going to shift over to that second point. It was A. When we left A, we went to D. When we left D, we went to C. When we left C, we went to B. And finally back to A. Okay, or you could have went with the one that started at C. Okay, and when we rewrite that one, we have to go to that middle point because again we have to start at A. So A, B, C, D, and back to A. And if you tried to do that with the last one as well, it actually comes out to be the same exact route as when you started with C. If you just reorder that one, it goes A, B, C, D, and back to A. So your final answer starting at A has to be one of these two choices, and it has a grand weight of 47. Okay. Moving on, we've got two more examples. Oh, I gotta shrink this down a little so we can see. Okay, first thing it wants us to do is label the graph and then perform the repetitive nearest neighbor. Depending on how you like to do it, you can use the table or you can use the graph to complete these. It does not matter which. It's all going to be preference on you. So, label the graph first. So we need to take all of these points from the table and we need to go ahead and label the graph. So, when we go from A to B, let me go ahead and get my marker back out here. And of course this would shift on me. I need it to be up farther. And I need my marker. Okay. A to B has a weight of 185. Okay. A to C is 119. A to D is 152. And A to E is 133. Okay. B to C had a weight of 121. B to D has a weight of 150. And B to E has a weight of 200. C to D has a weight of 174. C to E has a weight of 120. On your test, you may have to convert from a table to a graph or a graph to a table, so please make sure you're paying attention and you know how to do this. And your last one, D to E, has a weight of 199. Oops, that's a really bad 9. Okay, so performing the repetitive nearest neighbor. Let's start at A first. Okay, so A. When I leave A, I want to go ahead and go to, it looks like C, and that has a weight of 119. When I leave C, looks like my cheapest way is to go on to E. Okay, and that has a weight of 120. When I leave E, I've got two options left because I have to hit every point, so I can either go to B with a weight of 200 or D with a weight of 199. So we're going to head on over to D and add 199 here. And then finally go to B And D to B has a weight of 150. And then of course we have to go back home. So we've got to go back to A. From B to A is 185. Go ahead and grab your calculator and add all those up. 119, 120, 199, 150, 185. This gives me a grand total of 773. Okay. Same thing, but let's start at point B. If I start at point B, it looks like my nearest neighbor here. I'm actually going to use the table for this one and show you how to use the table. So if I look at column B, my smallest number here is the one that pairs up with C. So we're going to go B to C, and that's 121. Okay, so now I'm at C. So I want to look at this column. My nearest neighbor in that column is going to be A, and I haven't gone there yet, so we're good. So we add 119. Now I move on to column A. Column A, C is the shortest, but I've already been there. E is my next one. So that's 133. I have to go from E to D. So from E to D is this number right here, so 199. And from D, I have to go back to B. And D to B is 150. Okay. So 121, 119, 133, 199, 150. That gives me a grand total of 722. Okay. All right. Let's start at C. From C, my nearest neighbor is A. So we're looking at 119. Plus, from A, my nearest neighbor then would be E, because I can't go back to C. So that's 133. From E, my nearest neighbor, it would have been C, then it would have been E, but it would D now, so 199. Oops, 199. From D, we have to go to B. D to B is 150. And from B, we have to go to C. So we're looking at 121. This also gives us a grand total of 722. Okay. We need to start at D now. If I start at D, my nearest neighbor is B. It's 150. From B, we're going to head to C, 121. From C, we're going to head on over to A. It's 119. From A, we have to go to E. So A to E is 133. And from E, we have to go back to the starting point. So E to D is 199. 199, 133, 119, 121, and 150. Another grand total of 722. So far, it looks like that's going to be our smallest. We've got one more point, so we're going to go ahead and start at E. If I start at E, my shortest, or my least expensive, I guess we should say, since this is dealing with money, is going to be C. That's 120. From C, we're going to head on over to A for a total of 119. From A, C and E are both out, so we've got to head over to D. It's 152. From D, I've got to go to B. 150. And from B, I've got to go back to E. And that's going to be 200, it looks like. 350 plus 152 plus 119 plus 120. We're looking at 741. Okay, so our directions say label the graph and complete the repetitive nearest neighbor algorithm for a start of C. Well, it just so happens that our cheapest one of them, actually one of the three, because we're here, already starts at C. So you can go ahead and just use that answer. If you would actually rewrite the one that started at B, you would get the same exact answer that you had at C, as well as the one that started at D. If you just reorder them, they're going to go ahead and they're going to look exactly like the one when you started at C. We've got one more example to do, and our lesson's over. Perform the repetitive nearest neighbor algorithm for a start of B. This time they give us, oh, I did not mean to leave that graph up there. We're going to ignore the fact that this is even here on the right. Wonder if I can B, C, D, E. Oh, okay, that'll work too. So, what we're going to do is, you don't have to draw this chart out. I meant to erase it, but I can go ahead and use it, that's fine. So, we're going to use the table on the left to actually write out the nearest neighbors. What I did is I left blocks in here to fill out where we're heading. We start at A and we end at A. We start at B, we end at B. We start at C, we end at C. Okay, so when we start at A, it looks like our cheapest way to go is to head on over to F. Oh, I guess it would help if I switch back to a marker. We're going to head on over to F for a weight of 15. When we leave F, our shortest is going to be G, the total of 13. When we leave G, our shortest is technically F if you look down the G column or the G row, whichever way you want to look at it. We can't go to F yet because we've already been there. We can't go to A. So our next smallest one is going to be C, 28. From C, our shortest one would have been G. We can't do that. Our next shortest one looks like it's B, with 30. From B, we have to go to either D or E from B. D is 60, E is 80, so it looks like we're heading to D. And B to D is going to be 60. And D said we have to go to E. D to E is going to be 20. And then we have to return to A. So E back to A is going to be 35. All right. So let's add those up. We got 15 plus 13, 28 plus 30, 60, 20, 35. We're looking at 201. Okay. Let's start at B this time. We start at B. We're going to head on over to C. Okay. When I leave C, C is going to take me to G. Okay. When I leave G, my smallest one is F. So we're looking at 13 here. When I leave F, I can't go to G, so my smallest one's going to be A here. 15. When I leave A, my smallest is F, can't go there. My next smallest looks like it's G, we can't go there. So we're looking at D, 28. The only place I haven't visited is E. So we're going from D to E, that's 20. And from E back to B, that's 80. Okay, so we've got 30, 28, 13, 15, 28, 20, and 80. We're looking at 214 here. Okay, C. Our first stop should be G. I'm just going to circle them in the chart, and then I'm going to go back and I'll just add all the circle ones I have. So when I leave G, I need to go to F. When I leave F, my smallest is G, but I can't go there, so I've got to go to A. When I leave A, can't go to F, can't go to G, so we have to go to D. When I leave D, I've got B or E left, so we're going to go on to E. And then on to B. E to B is 80. And B back to C is 30. Okay, so we've got 28 plus 30 plus 28 plus 20 plus 80, 15, and 13. 214 again. Okay. If you don't like the table, you can always go back and you can draw this out as a graph. That's fine. Sometimes the table's a little more organized the bigger the graph gets because there's so many lines and numbers. Okay, if we start at D, my first stop should be E. If I go from E, my first stop should be D. Oh, can't do D, sorry. My bad. Okay, can't do D. So our next smallest one is going to be 32, it looks like. So G. So D, E, G. Okay, from G, my smallest one would be F. From F, can't go to G, but we can go on to A. From A, can't do F, can't do G. We can do D. No, we can't do D. That's our starting point. So we're going to have to go to E. Oh, wait, we already went to E. I lied. Can't do E either. What do we have left? Let's see. B and C. So we're stuck between B and C. Where are we heading? Where are we heading? B or C? It looks like we're going to head to C. So 50. And from C, we've got to head to B. So that's 30. And from B back to D, that's 60. All right, so 50 and 60 is 110. 30 is 140. 160. 192. Plus 15 and 13, that gives us 220. Okay. Almost done. The bigger they are, the harder this is, but just think if we were doing brute force. That would be 6 factorial. That's insane. Still a lot faster than brute force. Okay, so let's go back. We're starting at E this time. So my shortest is D. E to D. D to, looks like A. A to F. F to G. And we've got to do B or C. From G, we've got to go to B or C, so I guess we're going to go to C now. And from C, we've got to go to B. And B, back to E. Okay, so that's 15 and 80. 30 and 28. 20 and 13. 28, that gives us 214. Okay. 2 more times. Okay. All right, F this time. F goes to G. G goes to A. A goes to D. D goes to E. We've got to go to B or C. So from E, we're going to C, it looks like. And then from C to B. And from B to F. $28, $65, $30, $20, $48, $13, $22, $226. Unless this one beats it, it looks like 214 is going to be our lowest. Oh no, 201. Sorry, I missed that one at the top. See what happens. Last one. Here we go. All right. We're starting at G this time. G is going to go ahead and head to F. F is then going to head to A. A is then going to head to D. D is then going to head to E. We've got to go to C or B. So from E, we're going, it looks like C here. This trend of C to B. From C, we're going to B. And B, we've got to go back to G. 28 and 50, 30 and 20, 48, 15 and 13. 204 is our grand total. So our shortest one, our cheapest, however you want to look at it depending on what these numbers mean, is going to be our first choice here. Okay, but notice it says perform repetitive nearest neighbor for a start of B. So this now needs to be rewritten so it starts at B. So our final answer then is going to be B. B then goes to D. D goes to E. E goes to A. A goes to F. F goes to G. G goes to C. And C goes to B. And that's a grand total of 201. Your homework for tonight is going to be page 232, numbers 37 through 39, as well as number 41. And I will see you back here tomorrow.